Hello students, in the last session we did about the some of the properties of Laplace transform. We did first three properties: linearity property, first shifting property, multiplication by t raised to n property. Now, in this session we will do the remaining properties, that is division by t, periodic function, and also second shifting property. Yes, now first we will do the division by t property. Now, if L of f of t is equal to f of s, then L of f of t by t is equal to integration s to infinity f of s ds. That is, this is the fourth property, division by t formula. Division by t formula. If L of f of t is f of s, Laplace transform of f of t equal to f of s. Now, if the function f of t, when it is divided by t, if you take its Laplace transform, when the function f of t is divided by t, if you take its Laplace transform, it is integration s to infinity. It is integration s to infinity f of s ds. We can prove this formula just by using the definition of Laplace transform only. Very simple proof, and directly we can take as a formula L of f of t is equal to integration s to infinity f of s ds. Yes, now we will do some of the examples. Find the Laplace transform for the following functions. First one, 1 minus e raised to t by t, e raised to minus at minus e raised to minus bt by t. Third one, 1 minus cos t by t. Fourth one, cos at minus cos bt by t. Now, here in all these four example, function f of t, it is divided by t. Easily we can identify it. When the function f of t is divided by t, you can use the division by t formula. Yes, now we will do the examples. First example, you have to find the Laplace transform of 1 minus e raised to t by t. You have to find the Laplace transform of 1 minus e raised to t by t. How to find the solution? If you consider, let 1 minus e raised to t by t is equal to f of t by t. Then, what is f of t? F of t is 1 minus e raised to t. For the function f of t, you have to find its Laplace transform. how you are going to find the Laplace transform? If you consider L of f of t, Laplace transform of f of t is L of 1 minus e raised to t. Then L of 1, we know the basic standard formula. L of 1, first term, L of 1 is 1 by s minus second term. What is this one? Which form? Standard form, e raised to at. L of e raised to at, that is 1 divided by s minus a. What is your a here? E raised to at. A is 1, therefore it is 1 divided by s minus 1. Now this is nothing but your f of s. L of f of t equal to f of s. Now you can apply the division formula. What is your division formula? By using division formula, what is your formula? L of f of t by t is equal to integration s to infinity f of s ds. Now you substitute the corresponding values, that is L of, what is your f of t? 1 minus e raised to t divided by t is equal to integration s to infinity. What is your f of s? This is your f of s. It is 1 by s minus 1 divided by s minus 1 ds. Now integrate with respect to s between the limits s to infinity. Now integration 1 by s with respect to s, it is log s minus 1 divided by s minus 1 integration for the second term log of s minus 1 from s to infinity. Now simplify. What is this one? It is log m minus log n, log m by n, s divided by s minus 1 s to infinity. If you substitute directly the upper limit infinity, log infinity, it is not defined, then you have to simplify this one. How you are going to simplify? In the denominator you can take s outside, 1 minus 1 by s, s to infinity. Now this s will get cancels. Now substitute the upper limit, 1 by infinity is 0, 1 minus 0. Therefore your by putting the upper limit, it is log 1 minus s in place of s as it is log of 1 divided by 1 minus 1 by s. Again log 1 is 0, simplify. Now again if you take LCM, log s divided by s minus 1. If you take LCM, s minus 1 by s, s will come into the numerator. And again you can further simplify by using again log m minus log n, and here it is minus sign is there. If you take it inside the bracket, it is log of s minus 1 by s. You have to interchange the numerator and denominator. Here this minus sign will become plus sign just by interchanging the numerator and denominator. This is your required Laplace transform for L of 1 minus e raised to t by t. Yes. Now similarly we can do the other examples. Let us do the second example Second example, same type, there is no change in the procedure, same type, you have to do the examples. Now the second example is e raised to minus at minus e raised to minus bt divided by t. This is your second example. Now how to find the solution? If you consider e raised to minus at minus e raised to minus bt divided by t, this is equal to f of t by t. Your function is e raised to minus at minus e raised to minus bt. This is your function f of t. Now if you consider the Laplace transform L of f of t, this is L of e raised to minus at minus e raised to minus bt. What is this Laplace transform? This is the exponential function. First term L of e raised to at form, a is minus a, therefore it is 1 divided by s plus a. Then minus again second term L of e raised to minus bt, formula L 1 divided by s plus b. We know the formula L of e raised to at, one of the standard formula, 1 divided by s minus a. In place of a, here it is minus a, minus into minus it become plus a. Similarly here it is minus b, minus into minus it become plus b, s plus b, that is equal to your f of s. Now use the formula division by t formula. By using division by t formula, L of f of t by t equal to integration s to infinity f of s ds from s to infinity limit. Now substitute the corresponding value. Your f of t, L of e raised to minus at minus e raised to minus bt divided by t. Then integration s to infinity f of s. This is your f of s. It is 1 divided by s plus a minus 1 divided by s plus b into ds. You have substituted the value of f of s. Now integrate with respect to s. Now 1 divided by s plus a. What is this integration? It is log of s plus a. Then what about the second term? 1 divided by s plus b integration. It is second term minus log of s plus b from s to infinity. Then again use the logarithmic laws, log m minus log n. You can write log of s plus a by s plus b from s to infinity, log m minus log n, log m by n. Now if you substitute directly the upper limit log infinity is once again not defined. You have to simplify this one. How to simplify this one? In numerator and denominator, you take s outside, 1 plus a by s. If you take s in the numerator, if you take it outside, then in the denominator also you can take s outside from s to in. Now this s will get cancels. Now if you substitute the upper limit infinity in place of s, a by infinity is 0. Similarly the denominator b by infinity is also 0. 1 plus 0 by 1 plus 0. It is log 1 only. By putting the upper limit you are getting log 1 minus log of, you have to put lower limit s as it is 1 plus a by s by 1 plus b by s. Again this log 1 is 0. Then second term minus, again if you take LCM, it become log of s plus a by s plus b. Then s numerator s, denominator s will get cancels. Then you are left with log of s plus a by s plus b. Here it is negative sign. Usually we will avoid the negative sign at the end. Again by using log m by n, log m minus log n, and you can write it as log of s plus b divided by s plus a. You can write minus as plus, just interchanging the numerator and denominator, log of s plus b by s plus a. This is your second example. Yes. Now similarly we will do the next third example. What is your third example? Yes. Now we will do the third example. Now the third example, it is 1 minus cos t by t, L of 1 minus cos t by t. You have to find the Laplace transform of 1 minus cos t by t. How to find the solution? If you consider 1 minus cos t by t is equal to f of t by t, then your function is 1 minus cos t only. Then find the Laplace transform of the function f of t, that is L of f of t, L of 1 minus cos t. Then use the basic standard formulas of Laplace transform. What is the first term? L of 1. What is the formula? L of 1 is 1 by s minus second term L of cos t, L of cos at formula, s divided by s square plus a square. A is here 1, 1 square is 1, s divided by s square plus 1, L of cos t formula. Now this is your f of s, L of f of t equal to f of s. Now use division by t formula. What is your division by t formula? L of f of t by t is equal to integration s to infinity f of s by f of s into ds. Now substitute the corresponding values. What is L of 1 minus cos t by t equal to integration s to infinity. What is your f of s? Now this is your f of s, 1 by s minus s divided by s square plus 1 ds. Now the next step is you have to integrate with respect to s between the limits s to infinity. How to do this integration? First one you are doing as usual 1 by x integration log x. What about the second term? It is s divided by s square plus 1. Here you have to use the basic integration formula. We know that standard formula integration f dash x by f of x dx. It is log of f of x. By using this formula, we can integrate. What is this differentiation? S square plus 1 differentiation is 2s, but here it is only s is there. You have to make adjustment in the function, and in order to take common outside, you multiply numerator and denominator by 2. Here you are divided by 2, numerator first term you are multiplying by 2. Similarly, second term minus 2s by s square plus 1 into ds. Now, easily we can integrate with respect to s. Now, 1 by 2 is constant. Here you multiplied numerator 2 and denominator also 2. Now, integration is with respect to s. 1 by 2 you have taken as constant, then it is 2 is constant, 1 by s is log s minus log of, here it is 2s by s square plus 1 integration. By using this formula, integration f dash x by f of x dx, log f of x, it is log of s square plus 1 into ds, or it is 1 by 2, it is log s square log m raised to n log m, basic formula logarithm, log of s square plus 1 from this is from s to infinity only, s to infinity. Now, log m raised to n log m, then again simplify, it is log of s square divided by s square plus 1 from s to infinity. Again, if you put directly the upper limit minus lower limit, by putting the upper limit it is log infinity, which is not defined. Then how to simplify this one? You have to avoid the value of log infinity. It is log of s square, numerator you are keeping as it is, denominator s square you can take it outside, 1 plus 1 by s square from s to infinity. Now, this s square will get cancels, and if you substitute the upper limit, what happens? 1 by infinity is 0, 1 plus 0 it is 1, it is 1 by 2 log 1 minus, this is your upper limit is infinity, this s square will get cancels, 1 by infinity 0, 1 plus 0 1, it is log 1 minus lower limit s as it is log of 1 divided by 1 plus 1 by s square. Now, as we know, log 1 is 0, log 1 is 0. Again, if you take s square outside, s square as LCM, what you are getting? Now, this equal to 1 by 2 minus log of s square divided by s square plus 1 you are getting. Now, if you take LCM, s square as LCM, you will get 1 by 2 minus log of s square divided by s square, or you can write, here we have minus log is there, you can write in the positive log, minus sign you have written as plus sign, then you can interchange the numerator and denominator. It is 1 by 2 log of s square plus 1 by s square. This is the third example. Similarly, we can do the other examples. Other example, we can do it. Now, I hope you understood the procedure how to find the Laplace transform by using the division method. Now, we will move to the next property, Laplace transform for the periodic function. Laplace transform for the periodic function. Fifth property, we know what is a periodic function. What is periodic function? Now, a function which repeats itself at equal intervals is called periodic function. A function which repeats itself at equal intervals is called periodic function. But mathematically, how will define this one, periodic function? Yes, mathematically we can define the periodic function, a function f of x, a function f of x which satisfy the equation f of x equal to f of x plus capital T. Then the function is said to be periodic function with period capital T. Yes, now what is the Laplace transform of for a periodic function? Now, if a function f of t is a periodic function with period capital T, that is f of t plus capital T is equal to f of t, then L of f of t equal to 1 divided by 1 minus e raised to minus st integration 0 to capital T, that is period, into e raised to minus st f of t dt. What it means? If a function, given function f of t is a periodic function, that means f of t is satisfying the equation f of t equal to t plus capital T. That means function f of t is a periodic function with period capital T. Then if you take its Laplace transform, L of f of t is equal to 1 divided by 1 minus e raised to minus s into capital T integration 0 to capital T e raised to minus st f of t dt. It is 1 divided by 1 minus e raised to minus st integration 0 to capital T e raised to minus st f of t dt. This is the formula for Laplace transform for periodic function. Now, we can prove this formula just by using the definition of Laplace transform, again by using the substitution u equal to t, u plus t, u plus 2t, u plus 3t and so on. After simplifying, you will get the equation 1 divided by 1 minus e raised to minus st integration 0 to capital T e raised to minus st f of t dt. You must memorize the formula. Yes. Now, we will do the some of the examples. Now, the first example, given f of t is equal to e, which is defined in the interval 0 less than t less than a by 2, is equal to minus a by 2 less than t less than a. That means function is defined in the interval 0 to a by 2 and a by 2 to a, and here f of t plus a is equal to f of t. Then you have to show that L of f of t equal to e by s tan h hyperbolic function tan h a s by 4. Now, what is given here? Here given function f of t is e, which is defined in the interval 0 to a by 2, and also it is defined in the interval a by 2 to a. This is your given function, and here f of t plus a equal to f of t. Now, the function is defined in the two intervals 0 to a by 2 and a by 2 to a, and it is given f of t plus a equal to f of t. What it means here? Here if you compare this one f of t equal to f of t plus capital T, that means here function is a periodic function. Function is a periodic function with period t equal to a. That means you have to use the Laplace transform of periodic function formula. What is that formula? L of f of t equal to 1 divided by 1 minus e raised to minus st 0 to capital T e raised to minus st f of t dt. This formula you have to use. How to do the problem? First you have to substitute the value of a, value of period, that is capital T value you have to substitute. Then what about the interval? It is 0 to a by 2, a by 2 t. If you put t equal to a, then it becomes 0 to a. Then you split the interval 0 to a, total interval 0 to a, you can split the interval 0 to a by 2, a by 2 to a. Then afterwards you can substitute the value of the function f of t as e in the interval 0 to a by 2 minus e in the interval a by 2 to a. Then afterwards you have to integrate with respect to t, substitute upper and lower limit, simplify, you will get the required result. What it is given? L of f of t is e by s tan h a s by 4. We will get the required Laplace transform. Yes. Now, we will do this example. Now, this is the given function, you can call it as equation 1, given function. Here f of t is a periodic function with period capital T equal to a. Now, by using Laplace transform of periodic function formula, you have to memorize the formula. What is that formula? L of f of t equal to 1 divided by 1 minus e raised to minus st. Then what is integration 0 to capital T e raised to minus st f of t dt. As I told, first you have to substitute the value of t, that is period t as a here as given in the function. Now, this is equal to 1 divided by 1 minus e raised to minus s a integration t is a e raised to minus s t f of t dt. You have substituted the value of the period t as a. Now, you can according to the given function, you have to split the interval 0 to a as 0 to a by 2 e raised to minus s t f of t dt plus a by 2 to a e raised to minus s t f of t dt. You have splitted the interval 0 to a as 0 to a by 2 and a by 2 to a. Now, substitute the value of f of t. In the interval 0 to a by 2 it is t, in the interval a by 2 to a it is minus e. Just substitute the corresponding value of the function. In the interval 0 to a by 2 it is e. Then you see here what you have to substitute. In the interval a by 2 to a it is minus e dt. Now, integration is with respect to t, first term as well as second term. Then this capital E is constant with respect to t. You can take e outside the integral sign, e divided by 1 minus e raised to minus as. Now, 0 to a by 2 e raised to minus st dt if you take e outside the integral sign. Similarly, for second term, integration a by 2 to a, and you can take minus sign also, you can take as common outside, plus into minus, this is minus integration a by 2 to a e raised to minus st into dt. Now, integrate integration of e raised to x dx, e raised to ax by x. Now, you can easily integrate 1 e divided by 1 minus e raised to minus as. You can do the integration with respect to t, e raised to minus st by minus s from 0 to a by 2 minus second term e raised to minus st by minus s from a by 2 to a. Integration of e raised to ax dx, e raised to ax by a is here minus s. Integration is with respect to t only. Now, easily we can simplify, just substituting upper limit minus lower limit and just simplify. What you will get? Simplify what you are getting, just we will see. Yes. Now, you can simplify. Now, this is e divided by 1 minus e raised to minus as. Now, simplify. First, you substitute the upper limit minus e raised to minus s a by 2 by s upper limit minus lower limit minus e raised to 0 by s. This is upper limit minus, similarly second term upper limit is a minus e raised to minus sa by s minus e raised to minus sa by 2 by s. Now, this is your upper limit minus lower limit. This is for the first term, This is for the second term. Now simplify carefully. You have to simplify plus and minus sign. E divided by 1 minus e raised to minus as. Now it is minus e raised to minus as by 2 by s. Minus into minus, it is plus. E raised to 0 is 1. It is 1 by s. Then minus into minus, it is plus e raised to minus as by s. Then minus into minus plus. Plus into minus is minus e raised to minus as by 2 by s. Now simplify. Again further simplify. Now what you have to get in terms of hyperbolic functions? Still further simplify. What is e divided by 1 minus e raised to minus as? What is denominator? S is common. You can take numerator. This is the first term. You can write it as 1 first term, and this is last term. It is 2 times minus 2 e raised to minus as by 2. Then third term you can write e raised to minus as. Now you can simplify. How you are simplifying? Now this is e by 1 minus e raised to minus as. Denominator s as it is. How you are simplifying this numerator? A minus b whole square 1 minus e raised to minus as by 2 whole square. A minus b whole square. A square minus 2ab plus b square. Now further you can simplify. This is e divided by, again use the algebraic formula. This is a square minus b square. You can write 1 plus e raised to minus as by 2, 1 minus e raised to minus as by 2, and this is 1 minus e raised to minus as by 2 whole square divided by s. Now this is get cancels. This is 1 minus e raised to minus as by 2. Now still further you have to simplify. Still further you have to simplify. Now you have used the a minus b whole square formula. Here a square minus b square, a plus b into a minus b. Now if you simplify still further, it is e by s, e denominator s. Now it is 1 minus e raised to minus as by 2, denominator 1 plus e raised to minus as by 2. Now this is not your required result. You have to write in terms of hyperbolic function, e by s. Now to write in the hyperbolic function, you have to make adjustment in the function. You have to e raised to as by 4, e raised to as by 4, multiply and divide by e raised to as by 4. Then you can write in terms of hyperbolic function, which is your required result. Here it is given in the problem, prove that or show that. Until that you have to do the simplification. This is very important. E by s, you have multiplied and divided by e raised to as by 2. What happens? E raised to as by 4 minus e raised to minus as by 4. If you take it inside the bracket, it is e raised to as by 4 plus e raised to minus as by 4. Now what is this one? By definition of hyperbolic function, tan h as by 4. Yes, now we got the result, e by s tan h as by 4. What is your LHS? L of f of t only, L of f of t, we got the required result. Always the result should be in simple form, not so complicated, not so big also. Usually the result should be in the simplified form. To remember or to write, you have to write in the simplified. End result should be in the simple form. It is E by S tan H AS by 4. This is the first example. Now similarly, we can do the other example, second example. Second example. What is this? What is the second example? Now find the Laplace transform of f of t. Now f of t is defined in the interval 0 to a and 2a minus t, a to 2a. Then f of t plus 2a equal to f of t. Now you have to find the Laplace transform. Here important is use how to, where and how to use the formula, which formula to be used. Here it is given clearly f of t equal to 2a, f of t plus 2a equal to f of t. It is clearly, it is given f of t plus capital T is f of t. That means given function is a periodic function with period capital T equal to 2a. Then you have to use the Laplace transform of periodic function from this formula, you have to use it. So in the next session we will do this example and also one more last property, that is second shifting property. Okay, we will do it in the next session. Thank you.